Alrighty. So now we're officially in Module 3. So if you're watching this, this is Module 3. Alright, and we're going to start with quadratic functions. Basically, this is just parabolas. So notice the first words here are a parabolic function, and you can even see the shape below. Alright, so first we're starting with the formula that most people know already. Ax squared plus bx plus c. When you're dealing with the parabola, we call this the expanded form. And when we're dealing with this, the expanded form tells us a couple things. So ax squared plus bx plus c. So let me rewrite it up here just so I have room. So we'll start with a. So a tells us if the graph is pointed up or down. So is it a normal parabola or is it a flipped parabola? All right. B by itself doesn't really tell us much. C, on the other hand, this tells us what the y-intercept is. And there's a quick proof from that. The y-intercept is the value when x equals 0. So the y-intercept is y when x equals 0. Well, if you plug in 0 into this equation, a times 0 squared plus b times 0 plus c, notice that these two things cancel out, and you're left with just c. Okay, so that's why that c value is the y-intercept. So anyway, that's what the expanded form tells us. It tells us if it's pointed up or down, and it tells us the y-intercept. Now in the graph, the y-intercept is this point right here. Okay, so here, notice it says a is positive. And like I said, it's normal or flipped. Since a is positive, we have a normal parabola. If a is less than 0, we have a flipped parabola. Hold on, let me erase that. There you go. So anyway, let's kind of focus on this graph real quick. So notice the way this graph's set up. For a regular parabola, we have x-intercepts. So the x-intercept is when y equals 0. Or let me rewrite it as when equation equals 0. That's what an x-intercept is. My cats are deciding to play now that I started recording. Fun times. All right, the y-intercept is when x equals 0. Notice the difference between the two. There's a big difference. One is when the parabola equals 0, that's the x-intercepts. When x equals 0 is the y-intercept. Okay, the vertex is this very important point on the bottom, and that's where the parabola turns around. In this section, they give the vertex a special name. They go h, comma, k, where h is the x value and k is the y value. All right, now the vertex is, for all intents and purposes, this is the most important point on the parabola. I don't know why I'm putting the arrow pointing there. Let me put the arrow over here. It's the most important point. Because it's where the parabola turns around. Okay, so whenever you see a parabola, you think of the turning around shape. And the turning around part is the vertex. Now the other part is the axis of symmetry, or the line of symmetry, otherwise known as the axis of symmetry. So instead of line, you can see axis instead. It's the same thing. Now the formula for this, well, in this specific case, it's 1. But in general, because our parabola doesn't have to be at 1, in general, the formula is x is equal to, and notice that it goes through, forgot to put another highlighter here, but it goes through the x value of the vertex. So the x value of the vertex generically is h. So in general, my axis of symmetry is x equals h. That's the only x value that it goes through. Now the axis of symmetry is an equation. You must have the x equals or it's incorrect. Nothing's worse than when you're doing your homework and you forget the x equals and you get the right answer, but it counts it wrong. So when you're doing the axis of symmetry, just remember it's x equals and then whatever the x value of the vertex happens to be. All right, so that's kind of the anatomy of a parabola. You got your x-intercepts, your y-intercept. A tells you if it points up or down. The vertex is the most important point, which they call h and k. And then the line of symmetry, or the axis of symmetry, is x equals, and then whatever the value of the vertex, the x value of the vertex is. So if we change this up a bit, let me see if I can go this way. All right. So if we flip it, I can make this going backwards. Okay. Notice that we have our axis of symmetry, which is still going to be x equals h. We still have our vertex, which is still h comma k. Again, the vertex is just that point right there. And you have your x-intercepts. Okay, and we don't know where the y-axis is, but let's just say I put the y-axis over here. Why not? Let's say this is the y-axis. Then this would be the y-intercept. Right? But notice it's the exact same thing that we had on the other side. Okay? So, same exact picture. Oh, one thing I did forget is the domain and range. When you're dealing with the parabola, the domain is negative infinity to infinity, whereas the range is just the y value of the vertex onward. It's just starting at the y value, going up. And the y value happens to be k. So that's why the range is, if it's pointed upward, is from k to infinity. Now, if you're dealing with an upside down parabola, the domain, I'm running out of room here, is negative infinity to infinity. The range, in this case, is pointed downward. So the y value is k, and it's for all the y value but going down. And so because of that, it's negative infinity all the way up to k. So on the homework, there's going to be some questions where they ask you for the domain and range. And if you happen to know the vertex, if you happen to know this point, right there in the middle, then you have everything you need. Because the domain is always going to be negative infinity to infinity. But the range is going to be from downward all the way up to the y value of the vertex, which in this case is k. I wish it was easier for me to change colors. There we go. All right, so let me pause the video real quick. Need to get to something. How can I pause it? Oh yeah, up here. Be right back. All right, sorry about that. So going back to the lecture. So we have the basic anatomy of a parabola. So now let's go into standard form. So it turns out that when you're looking at the expanded form is kind of useless. Yes, it tells us if the parabola points up or down, and it tells us the y-intercept. But the y-intercept isn't the most important point on the graph. The most important point by far is the vertex. And so that's why the standard form is much more important than the expanded form. So the reason why we like the standard form is it tells us the vertex. And it tells us the vertex just by looking at it. So if you look at this equation, there's h and there's k. That's the x value of the vertex and the y value. So that's why we love this form. Notice it's a little different. It's kind of quasi-factored. It's kind of factored. The reason why I say kinda is there's the plus k at the end. So it's not a complete factorization. It's just kind of factored with a little left over plus k at the end. But anyway, so we like this. We love this standard form. And so we're going to learn two ways on how to go from expanded. Remember, expanded is more like that, to standard. And standard makes us happy because it has the vertex. So expanded has the y-intercept, which that's the face you make because the y-intercept's not really an important point. But here, the standard form gives you the vertex. And so you're like, yay! And you get your answer. All right. So to convert from standard form, we're going to use the following formula. Okay. So you're given expanded form. So you're given A, B, and C. I don't know why I wrote it way up there. A, B, and C. So given these three things, H is merely negative B divided by 2A, and K, it looks really complicated, but all this is saying is that just plug H into your equation. Why? Because remember that this is the X value, and this is the Y value. If you know the X value, plug it in, and you get your Y value. So this is the formula that you must memorize. Must memorize. All right. So let's do these two examples and to show you how we convert from one to the other. So I have 3x squared minus 12x plus 7. Looking at this, I can see that A is equal to 3, B is equal to negative 12, and C is equal to 7. So I already know A. Notice A is in my formula. So the first thing I'm going to do is I'm going to find H. It's negative B over 2A. So it's negative over 2. And all we do is we plug in B and A. So B is negative 12 and A is 3. So we work it out. Double negative is positive. 12 over 6 is 2. So we got our H. Now K, on the other hand, K is just what you get when you plug 2 into the equation. So I'll switch colors for K so it won't be all the same color. So K is going to be equal to 3 squared minus 12 plus 7. And I just plug in the 2 that I found. 2, 2. And when you do that, we end up getting our answer. So 2 squared is 4 times 3 is 12 minus 24 plus 7. Now, you know you've done this right when you see a special pattern happening with these numbers. Notice that this 12 and this negative 24. The second number is double the first and opposite sign. Okay? That always happens. This is a guarantee. So when you're plugging in your vertex, when you plug it in and you get your three numbers, if the second number isn't double the first and opposite sign, then something's wrong. It's always going to be like that. If it was 6, it would be negative 12. If it was 5, it would be negative 10. If the first one was negative 3, this one would be positive 6. So anyway, that's just a heads up. Anyway, so we have our values. I can chug this out. So this equals negative 12 plus 7 is negative 5. And so we have our h and our k. So I got everything I need. I know my a, I know my h, and I know my k. So now I can just recreate my formula. F of x, so let me try to, having trouble with screen real estate today. So the formula is f of x equals a x minus h squared plus k. So I just plug in the numbers I found. I know that a is 3, x minus, I know that h is 2, and I know that k is negative 5. And there we go. Kind of messed up on the ceiling there. Right. So we have f of x is 3 times x minus 2 squared minus 5. So that one was a happy one. The reason why I say it was happy is all the numbers worked out. There were no ugly numbers, no distracting numbers. And so that's not always the case. Sometimes when you're dealing with these, I'm trying to get everything fixed up. Sometimes you'll get a number that's, whoa, look, it's so tiny. There we go. Sometimes you'll get a number that's pretty nasty. And that's what the second column is for, to kind of show you that sometimes not everything works out in your favor. So let's do this one. Again, we know that A is 3. Sorry, wrong problem. A is 2. B is negative 10. And C is 1. Again, they told me A, so I already have that. But now I can figure out the rest. So I know that H is negative B divided by 2A. So negative B is negative 10 over 2 times A. A happens to be 2. And so I get double negative, that's a positive, 10 over 4. I can simplify that. 5 over 2. When you're dealing with these, no decimals. Unless the problem was given to you in decimals or it's a word problem, leave it as a fraction. We want to keep it exact. So now that I have that, I can figure out k. K, I just plug it in. 2 squared minus 10 plus 1. I plug the 5/2 in there. And you can use your calculator here. I don't mind. But when you work it out, you get 2 times 25, that's 50. You get 50/4 minus 50/2 plus 1. And again, notice what I mentioned earlier. You have these two terms. Notice that 50/2 is double 50/4. I'll write it to the side. Need to change color. So 50/4 minus 50/2 is just 100/4. So notice that the second number is double the first number, but with opposite sign. Anyway, so based on that, that's my little check to know everything's going all right. But you work it out, and that gives you negative 50/4 plus 1. So plus 1 is the same as saying plus 4 over 4. I'm not using a calculator. I probably should. So you work it out, and you get negative 56 over 4. And I'll just use my calculator. Y. 50 over 4 minus 50 over 2 plus 1. The math frac. Yeah, negative 23 over 2. Yeah, I was right. Sometimes I don't trust myself. Okay, so I know my A, I know my H, I know my K, and so now I can just plug it into the formula. F of x is equal to A. I'm using this formula up here. F of x is equal to A which is 2, parentheses, x minus 5 halves, close the parentheses, squared, minus 23 over 2. There you go. So on the homework, there's going to be some problems where they say, convert this parabola to standard form. And really all they're telling you to do is to find the vertex and just plug it into the formula a parentheses x minus h squared plus k. All right, so I'm going to take another break. My cat broke something, so I'm going to go see what happened. They're very active right now. All right. Anyway, going back here. So that was the easy way to go from expanded to standard form. Now the hard way is to do it manually, and it involves this term that many people may know and love called completing the square. And so there's all these blah, 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 blah to go through, but we don't have to worry about that because I made a little table, and this table kind of walks us through it. So I want to show you the manual way to do it. Now, it's not covered on your homework, but I guarantee you it's going to be a bonus on the exam. All right, anyway, so let's look at this first one. We have 3x squared minus 24x plus 11. So we have to write it in order. Well, I already said it in order, but we have f of x is 3x squared minus 24x plus 11. We call that descending order because the exponents descend in power. Notice that's a 1. And then this is really x to the 0. So the exponents go 2, 1, 0. So anyway, it's in descending order. Now here's what we're going to do. We're going to factor out the first, or the a, which in this case, notice that a equals 3. I'm going to factor the a out from the first two terms only. That means that I'm only going to factor it out from these two terms. When I do that, I get f of x is equal to 3 parentheses x squared minus 8x plus 11. So that's my first step. Okay. Notice we do not factor out the x. So if I look at these two terms that, yes, they both have x in common, but do not factor out the x. There's a reason why. All right. So what we're going to do, I'm sorry, guys. I keep getting interrupted. I think I just picked a bad time to do my recording. Anyway, so we don't factor out the x. So now here comes the completing the square part. Whenever you do that, you're going to have a number in front of x. In this case, it's 8. And actually, I need to expand on that. It's not just the 8, it's the negative 8. And so we're going to take half of that number. So half of negative 8, and we're going to square it. Half of negative 8 is negative 4. And when I square it, I get 16. Okay? Now, keep an eye out on this number. It's going to come in handy. But we're going to keep this 16. This 16 is our special number because what we're going to do is I have f of x equals 3 x squared minus 8x. What I'm going to do is I'm going to add the 16 and I'm going to subtract the 16. So notice that this is legal. It's legal because 16 minus 16 is 0. So we didn't really change the problem in any way. So I got that, and then there's the plus 11 on the outside. So why would anyone want to do that? Well, the reasoning behind it is these first three terms now are a perfect square. So those first three terms, x squared minus 8x plus 16, that's x minus 4 squared. And if you're really bad at factoring, the number before you square it, in this case it was a negative 4, happens to be the same as that number right there. It always works out like that. But anyway, I kind of rewrite everything that's around it. The minus 16 was not involved in the perfect square. Only the x squared was, the negative 8x, and the plus 16. So I'm going to put the minus 16 right there. There was parentheses around the whole thing. The 3 in front. And f of x equals. All right, and we're almost done. The next step is to get this 3 and distribute it to the inside. Now there's only two things here. There's the square term and the negative 16. So we distribute the 3 to each. And this gives us f of x equals 3, parentheses x minus 4 squared, minus 16 times 3 is 48, plus 11. And then all we got to do now is combine these two things. So if I get my calculator and I do negative 48 plus 11, I get negative 37. There you go. And that is basically this whole process. So notice it's the same thing as negative b over 2a. If I looked at my original equation and I did negative b over 2a, my b would be negative 24, and my a would be 3. So that would be 24 over 6. 6 times 4 is 24. And notice that that matches the 4 that's right there. Now you can go, I'm going to do this in my calculator just so I don't have to write it in there. But if I plug in 4 into the original equation, I would get 3 parentheses 4 squared minus 24 times 4 plus 11. And notice you get negative 37. And that's what I get when I plugged in 4. So if you had done it the short way, you could have got the answer really easily. You just find your h, plug it in to find k, and then you can go straight to the answer. But this is all the math that's required behind the scenes. This is where the formula comes from. It's just a shortcut to avoid doing all 6 of these steps. All right, so let's go do it. Let's do the hard example. I would leave this to y'all, but it's a little tough. All right, so I'm going to start with the same thing. I have f of x is equal to 2x squared minus 5x minus 13. So my first step is to factor the a out of each term. But notice that we can't really factor an a out of there yet. So what I have to do is be a little clever. I have to rewrite 5 as 10 over 2, because that's what 5 is. Now I can factor the a out. So this is 2 parentheses x squared minus, if I take the 2 out, we have 5 halves left over. So that's what made this one ugly, is that when you were doing this, the 2 doesn't cleanly get taken out of 5. So you rewrite it so that the numerator is a multiple of 2, in this case 10 over 2, and half of 10 is 5. So that's how you take the 2 out. You're halving everything. 2 becomes 1, 10 halves becomes 5 halves. Anyway, to make things even uglier, now I look at my number. My number is negative 5 halves. I'm going to take half of negative 5 halves, and I'm going to square it. Half of negative 5 halves, that's just 1 half times negative 5 halves. That's just negative 5 fourths squared. And when you square it, you get the delightfully nasty number 25 over 16 u. So that means that I can rewrite my equation. I'm gonna skip the f of x because it's taking up space, but I get 2 parentheses x squared minus 5/2 x, and then that's the number that you add and subtract, plus 25 over 16 minus 25 over 16, and then I had the minus 13 at the end. And I know I ran out of room. Dang it. Oh, that's not what I wanted. There we go. Sorry about that. Okay, so we get minus 13. See how nasty that is? Gross. But remember that we're going to take a note of the number before we squared it, which was negative 5/4. Because when you factor this, that's what it factors into. We end up with f of x equals these three terms right here. It seems really ugly, but those three terms factor into x minus the number before you squared it, 5/4 squared. There's still the 2 in the front. Oh, sorry. I still got the minus 25 over 16 out here. I still have the 2 out front, minus 13. And now we just distribute. So if I distribute this, we have f of x equals 2 x minus 5/4 squared. If I distribute the 2, 2 over 16 is 1/8. Minus 13. And here I'm just going to use my calculator. But we end up with our final answer. 25 over 8 minus 13. Using my calculator. Math frac. Negative 129 over 8. Gross. Okay, so as a bonus on the exam, I'm probably going to do something like this. Because the easy example, it shows me that you know how to complete the square, you know how to get it manually. But when you get to algebra, or when you get to Cal 2, you're going to see a problem like this. Not every day, but every once in a while, you're going to be dealing with a problem, and your teacher's going to do this on the fly, and it's going to be like trip you out, like, what did you just do? But he's just completing the square. Anyway, so I know this page was just a bonus topic, but we covered it when I was at Blinn at my old college, and so I really wanted to make sure that you knew how to do it. It's an old topic that I don't know, I feel like I'm doing you wrong if I don't tell you about it. Anyway, now let's go into the good stuff. Getting the equation and just finding all the information we can about it. And again, another pause. All right. So when you get to this problem on the test, this is basically, this is going to be a classic test question. Let me make sure I unpaused it, because that would be embarrassing. Yeah, I unpaused it. Okay. So basically for this section, what I'm going to do is I'm going to give you a parabola, and you just give me everything you can possibly think about it. What's the vertex? What's the standard form? What are the x-intercepts? What's the y-intercept? What's the axis of symmetry? And then once you have all of that, graph it. So this is just a classic test question. So let's start. What is the vertex? Now here we don't have to do it the long, convoluted, completing the square way. We can just use a shortcut. So I know that my A is equal to -2. B is -12. and c is negative 8. So I know that h is equal to negative over 2 negative b, so negative 12, over 2a, negative 2. So that's positive 12 over negative 4, which is negative 3. So that's the h value of my vertex. Remember, this is the x value. So now I'm going to go and find the y value, my k. And all I got to do is plug in the x value. So negative 2 squared minus 12 times minus 8. And I just plug negative 3 in there. So k is equal to, see, that's 9. That's negative 18 plus 36 minus 8. And remember what I said earlier? If we look at these two numbers, this is double with opposite sign. So that means that we're in the right track. This is going to be right. So that ends up becoming 18 minus 8. And 18 minus 8 is 10. So here my vertex is negative 3, 10. You have to write it as a point. You can't just get these two values and leave them alone. Vertex is negative 3, 10. Okay, write it in standard form. Well, I already know my a, and I know my h and my k. So my standard form, I don't give you a lot of space because I don't want you to do it the way we did on the previous page. This is going to be its own separate question. What I want you to do here is just use the formula. F of x is equal to a, negative 2, parentheses x minus negative 3 squared plus k. Remember the formula for that. I guess I should have wrote that for it's too late. And so all I did was I plugged it in, and all that you got to do is remember that you have a double negative here. So that double negative turns into a positive. And so that turns into a plus 3 squared. And there you go. All I want you to do. That's why there's no room. So now we're going to go and look for the x-intercepts. So x-intercepts is basically when you get the equation and you set it equal to 0. So there's two versions of the equations that we have. We have the one that we just did, and we have the original. So let's do the one we just did. Negative 2 x plus 3 squared plus 10 equals 0. Notice that if I have this equation, I can just start by subtracting 10 right away. This gives me negative 2 x plus 3 squared equals negative 10. Then I can divide negative 2. So I have x plus 3 squared equals 5. I can take the square root of both sides. So x plus 3 equals, and when you take the square root of both sides, you have the plus or minus. And then the last step is just to subtract 3. So we end up with x is equal to negative 3 plus or minus square root of 5. That's it. So notice that using the standard equation to find the x-intercepts is happy. But it's not the only way to do it. There is another way. So what is that other way? And the other way happens to be the quadratic formula. All right. So since I don't have enough room here, I'm going to bring it up on another page. But if you really want to do it, you can. So the quadratic formula My equation was negative 2x squared. I already forgot it. You think I could remember 3 letters, 3 numbers? Negative 2x squared minus 12x minus 8. Okay. So what you can also do is you can set this equation equal to 0. Okay. Now if you do it this way, standard form equals, not standard form, expanded form equals 0. If you do it this way, the biggest mistake people make is they try to add the 8 to the other side. And they do that and they end up with negative 2x squared minus 12x equals 8. But that's bad times. Yes, it's legal, but it's not the right way you want to go. You end up running in circles. So please avoid doing that. What we're going to do instead is just try to jump straight into the quadratic formula. Notice that we're setting this equal to 0, so I can actually factor a negative 2 out. This gives me x squared plus 6x plus 4. And then if you divide by negative 2, that goes away. And so notice here I have smaller a, b, and c. So I can use the quadratic formula. And the quadratic formula is an equation that you must have memorized. Negative b plus or minus b squared minus 4ac, and the entire thing divided by 2a. The entire thing. So if I follow that formula, it's just going to be negative 6 plus or minus the square root of, and you can do the easy steps in your head. I know that 6 squared is 36, minus, I know that a times c is 4. 4 times 4 is 16. And then the entire thing divided by 2a, which is just 2. So this becomes negative 6 plus or minus square root of 20 over 2. So we try to do some work here. On the side, I know that 20 is 4 times 5. So that means that square root of 20 is square root of 4 times 5. But 4 is 2, and the 5 is stuck underneath. So this is negative 6 plus or minus 2 square root of 5 over 2. Divide each one by 2. And notice we get the exact same answer that we did on the other page. Negative 3 plus or minus square root of 5. I know a lot of people don't like the quadratic formula. In some cases, it's unavoidable. But in other cases, you can always use the standard form of the equation instead of doing the quadratic formula. So if you don't like doing this, then what I recommend to do is to first be sure that your standard form is correct, but set the standard form equal to 0, because notice there's no quadratic formula involved. You just add the number over, divide by a, square root, and that's it. So there's 2 ways to do it. Okay, so what is the y-intercept? The y-intercept is just let x equal 0. And if I let x equal 0, I'm going to go to my original equation. Minus 12x minus 8. I put a 0 there, and a 0 there. And my answer is just negative 8. So my y-intercept is negative 8. And yeah, we could write these as points. So for my x-intercepts, I could say negative 3 plus square root of 5, 0. Negative 3 minus square root of 5, 0. And the y-intercept, I could say, is 0, negative 8. So now what's the axis of symmetry? The axis of symmetry is just x is equal to the x value of the vertex. The x value of the vertex was -3, so x equals -3. So now we can combine everything and plot it on the graph. So let's go ahead and do that. Some easy points. I know that the vertex is -3, 10. So -3, 10. I know that's also the axis of symmetry. I'll pick a different color for that. All right. And I know that the y-intercept is 0, -8, way down here. I know my x-intercept is -3 plus square root of 5. I can go to my calculator to guess what that is. So I type it in my calculator. And -3 plus square root of 5 is about -0.76. So -0.76. And -3 minus square root of 5 is -5.24. So that's about right there. Okay, so I have those points. And now there's one more point that we're missing. Notice that this is 3 units away. So there has to be another unit on the other side. So here, I call this the mirror point, because it's the side opposite to the y-intercept. But once you have all those, you can kind of create your graph. There you go. So again, this whole thing is a classic not first question on the test, but the classic question that I'll ask on the exam, where I'll give you the parabola. You tell me what the vertex is, the standard form is. You find the x-intercept either by setting the standard form equal to 0 or by using the quadratic formula. It's up to you. Does not matter. And find the axis of symmetry and graph it. So on the homework you're doing for this section, they don't ask it all as one problem. One question may say just what are the x-intercepts, another question may say what's the vertex, and yet another question may say what's the standard form. But on the exam, I kind of put them all together, just giving you a heads up. All right, so what I want you to do is do this one on your own, page 4, and I'll make another video after this lesson, and you can see if you did it right. But I want to jump to the word problems because there's 4 of them. I'm going to do 2 of them, and I want you to do the other 2 on your own. And again, pausing the video. All right, final stretch. So let's do these word problems. So I'm on page 5, and it says the monthly profit for a company that makes decorative picture frames depends on the price per frame. The company determines the profit is blah, and they give you the equation, where price is the price per frame, and F of P is the monthly profit based on that price. So here, notice that this is like your X, whereas F of P, that's your Y value. So they say find the price that generates a maximum profit. Well, if you look at this, especially from this first term, we notice that this is an upside down parabola. Upside down parabolas look like that. So when they say find the price that generates a maximum profit, what they're looking for is they're looking for the maximum value, the vertex. Okay? And then they say find the maximum profit. So the price, notice that price is the X value. So they want the X value of the profit, so they want H. Whereas for B, they want K. Now here, find the price that would allow the company to break even. So when they say break even, if we have our parabola, then break even are these 2 points, which you notice are just the x-intercepts. So this is exactly what we did on the previous page. Sorry, 2 pages ago, where we found the vertex and then we found the x-intercepts. It's just that they're putting it in a word problem and it makes it sound a little more scary. So for this problem, if I find the price that generates a maximum profit, so let's find the vertex. So h is equal to negative 1 over 1. And remember, looking at this problem, a is equal to negative 80, bigger numbers, but we have our calculator. B is equal to 3,440. And C is equal to negative 36,000. All right, so negative B, need to give myself more room, over 2A. Can't believe I messed up the formula there. 2, and then A is negative 80. So I plug all that in. And this is negative 160. I put that in my calculator. And I get 21.5. All right. So since this is a money problem, I'm going to go ahead and leave the decimal because we're dealing with money. Price. Yeah. All right. And so this is the price that generates the maximum profit. $21.50. So notice we answered part A. So now we can go to part B. So for part B, I have K is equal to, and I have the equation, negative 80 squared plus 3,440 minus 36,000. And the number I'm plugging in is 21.5. Cats are breaking things. All right. So if I type that in my calculator, I have negative 80 times 21.5 squared. That's negative 36,980. Then 3,440 times 221.5, 73,960. Notice it's double with opposite sign. So everything checks out. And then minus 36,000. So if I type all these numbers in my calculator, negative 36,980 plus 73,960 minus 36,000, I get 980. All right. And F of P is the monthly profit. So here, where's profit? So it's not in thousands or anything like that. It's profit based on, yeah. So here the maximum profit, they achieve a maximum profit of $980. And it's a maximum monthly profit. Can't spell. All right, so that's A and B. And C just wants you to find the x-intercepts. So let's go ahead and figure those out. Again, I'm going to try to shrink everything so I can fit this on the screen. Now, I know we're kind of weak in the quadratic formula. And notice I never really did factor my equation. So I'm going to go ahead and use the quadratic formula just so you can get a hang of it. All right. So if I have this formula, I have And since the numbers are so huge, might as well just plug them all in. I know that A, oh, I have them all up here. So we have that A is negative 80. Turn on my highlighter, Gilbert. Come on. Click. Okay. So A is negative 80, B is 3,440, and C is negative 36,000. So here, I know that X is equal to, remember the formula, you have to memorize this formula. So I'm going to start way over here to give myself some room. So X equals negative B, so negative 3,440, plus or minus the square root of, now B squared, I'm going to type that in my calculator. And that is a ginormous number, 11833, 600, minus 4, A times C. I can do that in the calculator. A times C is negative 80 times negative 36,000 is 200 is, wow, 2,800,000. Yeah, that's a big number. 288 and then 4 zeros. And then the whole thing divided by 2A. And 2A is just going to be negative 160. So we can type this in the calculator. What I'm going to do is just type what's inside the square root. So plus or minus the square root of 11833, 600, minus 4 times 288 and then 4 zeros. And that's 313,600 over negative 160. So we're making some progress. So the square root of that number is 560. And that gives us our two answers. So we're going to have plus 560 and minus 560. So if I get negative 3,440 and I add 560 and then I divide by negative 160, I get 18. Or, and now negative 3,440 minus 560 divided by negative 160, and I get 25. So I get two answers here. 18 or 25. And so the price that would enable the company to break even at a price of $18 or $25. All right. So again, I just wanted to do the quadratic formula. I know a lot of people are scared of it, but all you're doing is you're plugging verbatim into this formula. And don't let all the things scare you. Just remember to plug everything in your calculator. Don't plug the whole thing in at once. That's the big mistake that people make, because you're going to make some kind of parenthesis error and everything's going to be wrong. So just do it step by step. Notice the first thing I did was I figured out what b squared was. And I figured out what a times c was. Again, that was just b squared. This was just a times c. Those are easy things I can do in my calculator. They're hard to mess up. And then notice that I didn't take the square root yet. I just typed in what was inside the square root, and then I took the square root. And then from there, remember that you have to do all of this first before you divide. So if you're typing this in your calculator, you need to put that in parentheses. All right. Anyway, so I want you to try this next one on your own. Notice it's the exact same problem as this one, except instead of talking about profits, it talks about a long jumper, but notice it's the same thing. When the long jumper jumps, they jump in the shape of a parabola, and their highest point is the vertex. So everything kind of matches what we did up here. So give that a shot. Notice the numbers are a little nasty, but I believe in you. All right, so now for the last problem I'm going to do, there's two of these area problems. I'm going to do the harder one, and then I'm going to let you do the easier one on your own. So, two chicken coops are to be built using 120 feet of fencing. Okay, so we have 120 feet of fencing. Here's a little diagram of the chicken coop. So if this is X and this is Y, this has to be X also. This has to be X also. This has to be Y. This has to be Y. This has to be Y. Okay? So if I look at this, there's 120 feet of fencing. So how many X's do I have? So that's the total, basically the sum of all the lines. So the sum of all sides is 3x plus 4y, and I know that has to equal 120 feet. So that's a set equation. Okay. So we also say, what dimensions maximize the area? Well, what's the area of a rectangle? The area of a rectangle is just length times width. In this case, I'm going to say that this is my length, and this right here will be my width. So my length is 2y, and my width is just x. And so that's my area. Now it'll change. Notice that the formula for the area will change based on your shape. This has the equation on top has a different number of x's and y's. So it's going to be a little different. But anyway, so I have two equations. I have a is equal to 2yx. Now what I'm going to do is I'm going to get this equation, my perimeter equation, and I'm going to solve for one of the variables. In this case, it doesn't really matter. I'm going to solve for x. Why not? So if I solve for x, the first thing I'm going to do is I'm going to subtract 4y. And then I'm going to divide by 3. And notice this equation, I can now plug into here, because that's what x equals. So a is equal to 2y times 120 minus 4y over 3. Okay, we can keep working it out. And let me rearrange the spacing. I'm just going to make this whole thing smaller. There we go. There we go. I got to zoom in. So this is in parentheses, and so I can kind of distribute. So a is equal to, that's going to be 120, that's 240. 240y over 3. If I distribute to the other one, I get minus 8y squared over 3. And 240 by 3 works out. I think that's just 80. Yep. And notice that we have a parabola. Our expanded form. So this one was really tricky. This is the only way to create the equation. You have to come up with the 3x plus 4y equals 120. You solve for one of the variables, and you plug it into the formula for the area of the chicken coop. When you do all the math, you end up with a parabola. Now this parabola has a is equal to negative 8/3, and b is equal to 80, and luckily c is equal to 0. So I know h is negative b over 2a. So b is 80, 2a, negative 8/3. And I'm just going to type this all on my calculator. I need to get crazy with it. So negative 80 divided by negative 16/3. In your calculator, be sure that this is in parentheses. And that gives me 15. So if h is 15, then k is 80 times minus 8/3 squared. And that's where the 15 goes. So we plug that into our calculator. It gives me 600. Okay. So let's answer the question. What dimensions should be used to maximize the area, and what is the area of the chicken coop? Well, notice that this here is my x value. This is my y value. But what is my y value? My y value is the area. So this 600 is the maximum area of the chicken coop. Whereas this 15 is one of the dimensions. It's the y dimension. So what was x? And that's where this formula comes in. I know that x is equal to 120 minus 4y over 3. So that's 120 minus 4 times 15 over 3. So 120 minus 4 times 15 divided by 3 is 20. So your dimensions, notice that when we did this, my x value, I say it's an x value, but it was really my y dimension. Well, I guess that's what I wrote above here anyway. Whereas this one is my x dimension. So that means that the dimensions used to maximize the area of the chicken coop were a 15 by 20. And we were feet, right? Yeah. 15 by 20 feet. I need to put A right there. And I don't know what my cats are doing. They're just going crazy. Anyway, so that's how you do that problem. And this is the hardest one that you'll see on the homework. But a far easier one is the one above it. So give the one above it a shot and let me know how you do. But it plays out exactly like this one does, except the numbers for it are a little different. All right, so let me know if you have any questions. Y'all got this. And again, I apologize for having to pause all the time on this lecture.